Let's have a look at one question from our homework on worksheet number 8, specifically question number 9, where we had three charges in a row. And we wanted to find the net field strength as a result of those three charges. Let's draw this out. It's critical in these questions, just like it was in those questions where we had three charges, and we wanted to find the force acting on one due to the other two. It's critical, just like in that situation, that we draw a diagram here. Here's the first charge. It has a value of positive 2.50 times 10 to the negative 2 coulombs. The second charge is to the right of the first charge, and its value is negative 4.00 times 10 to the negative 2 coulombs. And it is 60 millimeters to the right of the first one. And then we have our third charge, which is 5 centimeters to the right of the second charge. It's going to be positive 3.00 times 10 to the negative 2 coulombs. We'll label that number 3 and label it as 5.00 centimeters. And we want to find the field strength 2 centimeters to the right of the third charge. So we want to find the field strength over here to the right of that third charge, 2.00 centimeters. Man, there's lots going on here. Okay, we want to find the field strength right here. I'm going to just circle these in red because, well, not only are they not meters, but they're also different units. We got centimeters and we got millimeters all in the same question here. Charge number 1 is not at that point X where we're trying to find the field strength, right? Neither is charge number 2, neither is charge number 3. That means that all three of those charges are what? They're producers, right? If they're experiencers, then they've got to be at the point where you're trying to find the field. They're not. Okay? We're trying to find the field right here. None of those three charges are at that point. That means they can't possibly be experiencing the field. They have to be producing it. Now, there's three charges causing fields. Therefore, there's going to be three fields at point X that add together to give me the net field. The field caused by number 1 is going to point which way? It's going to point to the right. The field caused by number 1 is going to point to the right. How come, Nick? Good. The field goes out away from positive. To the right of a positive, the field is going to point to the right. Okay, pretend the other ones aren't there. If you can visualize this, just pretend those aren't there. The field goes out away from charge 1 because it's positive. Now, what about the field caused by charge 2? Which way is it? Right, left? It's going to be to the left. And how come? Because it points toward a negative. The field always points toward a positive, negative producer and away from a positive, away from, what did I say? Points away from a positive producer and points toward a negative producer. What about the field caused by number 3? It's going to point to the right. The field caused by number 3 is going to point to the right because number 3 is a positive producer, and the field always points away from a positive producer. So I've got all three of those field directions. Now I've got to find all three of those field magnitudes. We're going to say the field caused by number 1, kq over r squared. That's 8.99 times 10 to the 9. Times the charge of number 1, 2.50 times 10 to the negative 2, divided by r squared. What's r going to be here? Yeah, it's a total distance, right, from that charge number 1 to the point X where we're trying to find the field strength. So we're going to say 60 millimeters, which would be the equivalent of 6 centimeters, plus 5 centimeters, plus 2 centimeters is 13 centimeters, or 0.13 meters. Does that make sense? Got to be in meters here, right? And we got to add all those together. When we solve that, we end up getting 1.3299 times 10 to the 10 newtons per coulomb. Now we're going to do something very similar with the field caused by number 2, except this distance would only be 7 centimeters, or 0.07 meters. We end up solving for that field, and we get 7.3388 times 10 to the 10 newtons per coulomb. E3, that's the easiest of the three. The field caused by number 3, that's the easiest of the three because the distance is just what? We don't have to add anything together here, right? The distance is just 2 centimeters, or 0.02 meters. Solve for that one, and it works out to be 6.7425 times 10 to the 11 newtons per coulomb. And then what do I do with these? Add them up. E1 plus E2 plus E3. Make sure you put the little vector signs over it to remind you that it's not energy, right? It's not energy, it's electric field, two completely different things. Okay, E1 is going to be a positive value. E2 is going to be a positive or negative. How come it's negative? Because it's to the left, right? 7.3388 times 10 to the 10. And E3 is going to be a positive value again because it's to the right, 6.7425 times 10 to the 11 newtons per coulomb. Add these up, we end up getting 6.14, positive 6.14 times 10 to the 11 newtons per coulomb. So that means it's 6.14 times 10 to the 11 newtons per coulomb to the right. Make sense? I think you find with number 8 that it's real similar to that, except that number 8 you were trying to find the field strength midway between the two charges. And if it's midway between the two charges, you just got to be careful with that distance, right? Number 8, the distance between them was 4.5 centimeters. So the distance from charge 1 to point X would have been 2.25 centimeters. And the distance from point 2 to X would have been 2.25 centimeters again. Again, converted to meters as well, right? So just be careful with that. Don't use the 4.5 centimeters because that's not how far away from that point where either of the charges are. All right? Any questions there? Yep. Okay.
So when you were analyzing the direction of the charge,
Yep. Direction of the field, you mean?
of the field,
Yep.
it's like an object.
Yep.
Would it have made a difference if you were to, instead of say, because you looked at it from the perspective of object 1.
If I understand the question, you're misunderstanding a little bit what's going on there. Correct me if I'm wrong here. When we're trying to find E1, E2, and E3, each of these fields, when I'm trying to find E1, we're doing it from the perspective of charge 1. When I'm trying to find E2, we're doing it from the perspective of charge 2. And when we're trying to find E3, we're doing it from the perspective of charge 3. So whenever you're trying to find the field caused by one of these, 1, 2, or 3, what you want to do is pretend the other ones aren't even there. They don't even exist. So let me try to copy this over here. So if you're looking at the field caused by number 1, as far as you're concerned, this is all that matters. This is all that matters. Okay? That top diagram isn't there. If you're trying to find the field strength at this point caused by number 1, you're going to say the field at this point caused by number 1 is to the right. It goes away from a positive. Now, we're going to do something from a completely different perspective now, from perspective of charge 2. Okay, charge 2 is negative. Okay, the field at this point X caused by number 2, independent of the other ones, is to the left because it's toward a negative. Forget about number 1 right now. Okay, that's done and over. Okay, forget about number 3. We haven't dealt with that yet. We'll deal with that later on. Okay, we're looking just at charge number 2 right now, and it's to the left because it's toward a negative producer. We always have a field away from a positive. We always have a field toward the negative. Now, charge number 3 is positive. We're trying to find the field strength to the right of the third charge, the positive charge. We're going to say it's to the right because the field is always away from a positive. So all we're doing here, all we did in the original diagram that I had drawn up here, this way, and this way, was really combine these 3 diagrams that we had drawn here. Okay? So when we go from this one to this one, we're not doing them both from the perspective of charge 1. We're doing it from the perspective of the charge of a different charge. Charge 1, then charge 2, then charge 3. Does that kind of answer your question? Okay. Is that good for everybody? If it's helpful to to draw 3 separate diagrams like I have here, then do that. It's not necessary necessarily. Can you say that? It's not necessary necessarily. But it's up to you. If you can draw it on the one diagram like I did originally, that's fine. Okay, if you have a little bit of trouble with that, if it's easier to visualize it, drawing it like this with 3 separate diagrams, then draw with 3 separate diagrams, whatever works for you. Yeah, I know.
Would you ever give us a question where X is, say, between 1 and 2, instead of it being on one side of it, you know what I mean?
Like this. So, like with 2 charges, were you trying to find field strength right there?
But yeah, so there's like another chart.
Oh, but there's another one over here. I can't honestly recall a time when we've seen one like that, but it wouldn't be out of the question. As long as you had the numbers, then it really wouldn't be that big of a deal. Like let's say that I knew this number, and I knew this number, and I knew this number. Okay, let's say I know all those numbers. And let's say that charge 1 is positive. Let's say, what do you want to make 2, positive or negative? Negative, and charge 3 is? Okay, let's make that positive. Then we just say the field caused by number 1 is this way, to the right, because it's away from the positive. The field caused by number 2 is, which way, left or right? Pretend number 1's not there. Does it point away from or toward a negative? Yes. So E2 would also be to the right because it's toward the negative. E3 would be to the left because it's away from the positive. So you solve for each of those fields the same way as you did, the last question we just did. Be a little bit ickier just because, you're dealing with for the field caused by number 1, only this distance. The field caused by number 2, only this distance. And the field caused by number 3, you'd be dealing with this distance right here. But it really wouldn't be that much harder. You just have to be careful, that's all. Okay? So I don't remember a situation where we've seen that, but it certainly wouldn't be out of the question to get something like that.